The oxygen analyzer is an instrument used to measure combustion within the boiler. The boiler uses a forced draft fan, or FDF, to intake air for combustion. When FDF ventilation is reduced, incomplete fuel combustion occurs in the boiler, generating a large amount of dark smoke. Conversely, when ventilation exceeds recommended limits, heat loss occurs. The excess air takes heat with it as it is exhausted. Furthermore, excessive ventilation also increases NOx emissions. Proper FDF ventilation can be determined by measuring oxygen concentration in the boiler exhaust gas. The oxygen analyzer needs to be warmed up for 5 to 10 minutes before being used, so make sure to turn the analyzer on before operating the boiler. It is always necessary to know how much fuel oil remains, and whether or not the proper quantity of water has been supplied to the boiler. It is also necessary to know exactly how much crude oil, or LNG, has been loaded or unloaded. For these reasons, level meters are installed in most vessel tanks. The level meter is usually a glass tube connected to the side of a tank to allow for measurement by sight. The principle of the float-type level meter is to determine the level of a liquid by detecting the position of a float on the liquid's surface. Level meters vary according to manufacturer. Most float-type level meters make use of a float set inside a tank or measuring tube and then convert its position into an electrical signal. Microwaves are a kind of electric wave. Microwave level meters are so accurate that they are used for LNG and LPG tanks. But float-type level meters are also used as a backup measure. High accuracy makes the electrostatic capacity type level meter the most commonly used LNG tank level meter. This level meter can be regarded as a type of capacitor because two cylindrical electrodes are installed in the tank. The liquid's level is determined by measuring the capacitance between the two cylindrical electrodes. Pressure proportional to the product of the liquid level and the liquid density is known as the waterhead pressure, and it represents the amount of pressure at the bottom of a tank filled with liquid. Measuring waterhead pressure can tell you the amount of liquid in a given tank. This is the principle behind the pressure-type level meter. The flame detector, also known as the flame eye, is a type of optical sensor. A flame eye is installed near the nozzle of the boiler burner, monitoring the burner flame. When the burner flame is on, the flame's light passes through the sensor and is converted into an electrical signal. When the burner flame is off, the sensor ceases to produce an electrical signal. Installed close to the surface of a flywheel's turning gear, the proximity sensor measures propeller shaft revolution speed. The proximity sensor detects the presence of metal. When the flywheel rotates, grease applied to the turning gear may scatter and stick to the proximity sensor. Metal dust often gets mixed with this grease. If this happens, the proximity sensor may not work properly. To avoid this problem, when the ship is in harbour, it is advisable to wipe off any grease stuck to the proximity sensor. It is necessary to measure torque in order to calculate the ship's shaft horsepower. The output of the main engine is transmitted through the countershaft. When this takes place, the countershaft is distorted slightly. Torque can be determined by measuring the degree of distortion exhibited by the countershaft. There are several methods of calculating distortion. Here, let's look at the most frequently used methods. This is a torque meter that employs a sensor containing a special alloy. When shaft distorting force is transmitted to the sensor's length changes slightly. With this torque meter, it is possible to measure torque by detecting the slight change in the sensor's length. Another method is to detect distortion using turning gears and proximity sensors, such as tachometers. This method employs two sets of paired turning gears and proximity sensors. This method uses discrepancies in the respective sensor's output signals as the basis for calculating the value of torque. Flow meters are attached to the fuel oil line for the main engine, engine generator and boiler. Ship operating costs can be reduced by decreasing fuel consumption. This also reduces emissions of carbon dioxide, the main factor in global warming, and NOx, the main factor in acid rain. Of the various types of flow meters available, here we will focus on the oval gear flow meter. This flow meter features a pair of oval-shaped gears that are rotated by the flow of fuel oil. Fuel flow quantity is determined by measuring the number of gear rotations. The fuel oil heater is used to lower the viscosity of fuel oil supplied to the main engine from the fuel oil service tank. The viscometer is set near the fuel oil heater. It measures fuel oil viscosity and widens the steam system motor valve opening if viscosity is higher than a preset value. Conversely, it narrows the steam system motor valve opening if viscosity is lower than the set value. The transducer is used to obtain accurate data from the sensor, record it electronically, and send it to the control room. Though at first glance this may look like a terminal block, the transducer plays an important role in connecting the sensor and data logger, or sensor and electronic control device. Transducers convert data into analog signals. This data must be converted into digital format for recording, control, and display by computer, a task that is handled by analog to digital converters. This graph shows an analog signal drawn using fixed-time pulse width, a process known as sampling. Next, the heights of the sampled data are replaced with numerical values. When expressed as binary numbers, the numerical values look like this. In this way, data for temperature and pressure are converted into digital data and used in measuring devices and computers. Information is also recorded digitally on CDs and DVDs using combinations of ones and zeros. Playback of a music CD involves conversion of digital data into analog signals that are then output by a speaker. In this sense, a CD player is a digital analog converter, or DA converter. Proper use of testers makes it possible to measure voltage, current, and resistance value of electrical equipment, detect damage to the equipment quickly, and repair it. There are two types of testers, analog and digital. First, let's see how to use an analog tester. When a test lead touches the electrical equipment, the indicating needle moves according to the value of voltage or resistance of the equipment. Using the rotary switch, items to be measured can be selected from among DC voltage, DCV, AC voltage, ACV, resistance value, ohms, and DC current, DCA. A tester is used to locate defects by measuring the voltage of electrical equipment. To measure alternating current voltage, set the rotary switch to ACV. and to measure direct current voltage, set it to DCV. If the voltage range to be measured is not known in advance, set the rotary switch to the highest value in the measurement range. Make zero level adjustments before measurement. When the red and black test leads touch each other, check if the indicating needle points to 0 volts. If the indicating needle does not point to 0 volts, adjust the needle by rotating the adjustment screws with a screwdriver. Touch the test lead to the terminal of the electrical equipment to be measured. When measuring DCV, touch the red test lead to the plus side and touch the black test lead to the minus side. If the indicating needle moves to the left side of 0 volts, the test leads have been reversed. The test leads should touch their corresponding sides. When the indicating needle moves only slightly, the measurement range is too large to be measured. In this case, make the measurement range smaller and measure again. Conversely, when the indicating needle moves all the way to the right, the measurement range is too small. In this case, the measurement range should be increased before measuring again. Frequently, a weak signal from the sensor is input in a transducer and then converted into an electrical signal of between 4 mA and 20 mA. A tester to verify the operation of the sensor and transducer can be used to measure a weak current, but not a heavy current like the one flowing through a motor. For a heavy current, a clamp meter should be used. Set the rotary switch to DCA. A measurement range of less than 30 mA suffices for measuring the sensor's output current, but when the range of the current is unknown, set the range to maximum. Make zero level adjustments before starting current measurement. Remove terminals from the circuit and the electrical equipment whose current is to be measured, and touch the test leads in such a way that the tester is serially connected to the terminal. Approach this activity with care, because it only takes a fraction of a second to damage the tester if the test leads are allowed to touch parallel to the circuit. In the resistance thermometer, the resistance value changes according to changes in the measured temperature. The resistance value is measured by using a tester to check whether the resistance thermometer is normal or disconnected. Set the rotary switch to measurement of resistance, ohms. When the resistance value to be measured is not known, set the measurement range to minimum. Make zero level adjustments, as in the case of voltage measurement. If the indicator needle does not point to 0 ohms, adjust the needle to 0 ohms. Failure to do so will result in an incorrect resistance value. Touch the test lead to the terminal of the device to be measured. If the indicating needle moves only slightly, increase the measurement range and then measure again. When the indicating needle moves sharply to the right, reduce the measurement range to get a more accurate measurement. Like the analog tester, The digital tester can also measure voltage, current and resistance. A certain type of digital tester is capable of measuring AC voltage frequency, temperature and even capacitance. As such, it is sometimes referred to as a digital multimeter. Items to be measured are selected by the rotary switch, but because in many cases range setting is done automatically, there is no need to set the range. With the digital tester shown here, measurement of voltage and resistance is automatic, but the range setting for current is manual. The test lead contact point differs only when measuring current. The precautions adopted with the analog tester should also be adopted when using a digital tester. For example, the practice of making zero-level adjustments should be followed before starting measurements. Refer to the instruction manual, because methods for making zero-level adjustments vary according to the type of tester. In the digital tester, voltage received at the test lead is converted into a digital signal, and the result is displayed as a numerical value on the display panel. If OL is displayed while measuring resistance value, the resistance of the object being measured is infinite. In other words, either the cable of the wiring or electric bulb is disconnected, or the switch is off. When OL is displayed while measuring voltage, the voltage being measured exceeds the tester's capabilities. Now let's think about how to locate defects with a tester using this circuit diagram. Here, let's assume a condition where the power source lamp does not illuminate, even when the MCCB is turned on. First, let's check the fuse. You can usually determine the state of a glass tube fuse by looking at it. If visual confirmation is not possible or is inconclusive, voltage can be measured at the output side of the fuse. Even if only one fuse is blown, voltage at the output side will be zero. In the event of a blown fuse, make sure to switch the MCCB off before removing the fuse. The resistance value of the fuse is measured by a tester. The fuse should be replaced if this value is infinite. That is, the needle is stationary in the case of an analog tester, and in the case of a digital tester, OL is displayed. In the event that cables connecting the terminal board with the white power source lamp have become disconnected, then while the MCCB is switched on, measure the voltage between the terminals of the white lamp. If the measured value is normal, the cables are not disconnected. If it is not normal, the cables may be disconnected. Switch the MCCB off, remove the cabling, and then measure the resistance at both terminals of the cables. If the resistance value is nearly zero, the cables are not disconnected. Conversely, the cables should be replaced if the resistance value is infinite. That is, the needle is stationary in the case of an analog tester, and in the case of a digital tester, OL is displayed. While the MCCB is on, measure voltage between the terminals of the lamp. If the lamp does not illuminate despite voltage being at a normal level, the lamp is damaged. The insulation resistance tester is commonly known as a mega. Electric equipment is made shockproof by covering electric cables with an insulating material like vinyl. However, since both humidity and temperature inside ships tend to be high, insulating materials are liable to deteriorate. The risk of electric shock increases if insulation resistance between the coil inside the motor and the case is reduced. As such, insulation resistance between the motor and the case should be measured at regular intervals. Here, let's see how to measure a motor's insulation resistance using a megger. Before measuring the insulation resistance, turn the MCCB off. Unless the motor is dismantled, the coil will not be visible. However, insulation resistance can be measured at the MC output terminal because the motor coil is electrically connected to the MC. So, use the megger's plus side test lead, red, to touch the MC output terminal. Use the other lead, black, to touch the ship's hull or the terminal to which the motor's ground wire is connected. Since many high-precision semiconductor instruments operate using low voltage of between 5 volts and 12 volts, they will break down if subjected to excessively high voltage. Damage usually occurs internally, making it difficult to determine from appearance alone that the semiconductor has been harmed. A megger measures insulation resistance by generating high voltage in the test lead. If a megger is used with a circuit board incorporating semiconductors, the semiconductors may be rendered unusable. Never use a megger for circuit boards incorporating semiconductors. It is possible to use a clamp meter to measure a heavy current like the one passing through the motor. Current flowing through the cables can be measured by a clamp meter without having to touch the cables. This means that current can be measured without having to turn off the equipment being checked. However, the clamp meter cannot accurately measure current flowing through basket-armored cables. Use this type of meter at parts that are free of armor. Now let's confirm the points to remember when measuring current with a clamp meter. Since the tip of the clamp meter incorporates a precision semiconductor component, never attempt to hold any object with the tip of a clamp meter or pull an electric cable with it. While measuring DC current, pay attention to the flow direction of the electric current. An arrow indicating the direction of the current is provided on the tip of the clamp meter. The arrow direction should match the direction of the current. When measuring the current flowing through the motor, note that there are 3 or 4 cables connected to the motor. Attempts to measure the current of all these cables at the same time will yield a value of 0. Measure the cables one by one. Please learn how to use the clamp meter properly to obtain accurate data.